My name is Carter Tiernan. I am an analytics translator at Uptake. What Uptake is we are a predictive analytics and industrial AI company. We work to put your data to work. We take the raw data coming from industrial machinery and we run it through machine learning algorithms and display it through our software to make sure that you guys can run your machines at the highest performance and predict failures before they actually occur. I'm actually just going to go into and show a little bit, some snippets of our actual live program. What you're seeing here is really a culmination of years of development and collaboration with our partners. What we do is we think of it in really three different fashions. There's visualization of data, there's actually analyzing and creating insights from the data, and then the third and most important step is actually making the customer act. I'll get into that in a little bit, but what you're seeing here is actually a map of all the assets that are currently being monitored around the Dallas area. As you can see, a lot of these assets, they constantly create hundreds, if not thousands, of data points per hour. But that's a lot for a human to really kind of pick up on and really be able to analyze and understand. So what we do is we use our machine learning algorithms as well as input from the customer to boil that down into what we call operational guidance. So all this data, our hundreds of models, can actually be boiled down into something as simple as a green dot or a red dot. As you can see intuitively, red dot probably means something is wrong. So if I click on it, you can see that the operational guidance is do not operate. What this means is we've actually taken the data from this asset, and we know that within 2 weeks, this asset is likely to fail. So what that means is that you don't need to worry about it right now, but you can start planning ahead to figure out when you need to shop this asset when it is done completing its mission. So we give a little bit more information about it. You can see that there's 1,854 faults. These are the faults that you're used to, the diagnostic information that comes off the asset itself. It's a lot of faults though. So when you actually want to make an action, you have to understand what needs to be done. So if I were to click on this, it brings me up to a page that actually integrates 6 different sources of information. This is a key thing that we've found when developing these solutions, is a lot of times operators, CMAs, people that have to actually work and make sure that the fleet is up and running, have multiple monitors up with many different systems. For instance, in this, they had the weather, they had their ERM, their asset management software, as well as, like, let's say SAP or how they do work orders. What we've been able to do is actually integrate all of that information into a single source of truth. So as you can see, we give the weather, we give information about the running hours, fuel, coolant, and I'll get into a little bit more of this data in a bit, but what I want to go down to is what we really care about, and that is why shouldn't I operate this asset? And as you can see, when you scroll down, the operating guidance is broken down into the subcomponentry of this asset. There's engines, there's control systems, traction, and we can see quite clearly that it's the engine that is the problem. And if we click into this prediction, we see that there's an engine oil pressure failure. Now this is our failure prediction model. What it does is it actually looks at previous failures to figure out the patterns of what a failure looks like. What it then can do is when it picks up on that pattern in the future, it can, one, show you the information that it used to create this prediction, and two, bring it down to that act stage. So if I'm a CMA and I say, hey, this seems like a pretty reasonable anomaly or failure, I can actually go down, I can check the data that supports this insight, and I can attach a troubleshooting guide. So not only are we saying that something is going wrong, we're telling you what is going wrong, and we're going to allow you to attach steps of actually how to fix this problem. These are really interesting. It's an additional layer of machine learning. What it can do is if the technician that goes and actually works on this asset says that step 3, fix the problem, our machine learning algorithms will take that into account and actually start prioritizing step 3 over the less helpful steps. Now, we integrate back into SAP, Maximo, whatever work order system that you use at your operations. So you can work in the workflow that's currently at your operations. Now, One very interesting thing about actually putting your data into a single system is you can start unlocking operational efficiencies that you couldn't even have thought of before. For example, this customer was doing multiple diagnostics when the asset came into the shop. They'd run it and they'd actually burn fuel to see if they could get diagnostic information off it before they fixed it. What we realized when we went down to their shops and then we saw them doing these tests was, hey, we already have all this information. Moreover, we have this information when the asset is when it's actually on a mission working under real operational parameters. So we created what we call the virtual load test. And if I click this button, what it does is we'll actually populate all the diagnostic information that they used to see what was wrong with the asset based off its most recent mission, its most recent operational parameters. Moreover, it will actually go through and flag the ones that are of most interest or maybe out of bounds. Now this saves them, I think they were spending around $80,000 a year per asset on fuel by having to run them during these diagnostic tests. So if you have a fleet of 100, that's $800,000 right there. There's one last thing I want to go over, and that is what we call AESS. Bring it here. Do I have enough time? Yep. What this shows is actually a breakdown of all the fuel usage. Usually when the asset is stopped, it should either be turned off so that fuel isn't being used, or it can be put into neutral. It can some state that uses less fuel. However, given certain operational parameters, or maybe even an operator, the driver of the vehicle, they will stop this from happening so they can, let's say, have the air conditioning running, or maybe they forgot to. What this actually does will break down that fuel usage into the key things. So maintenance-driven idle time, operator-driven idle time. So not only can you see what financial impact these kind of behaviors are having on your operation, but you can break it down into the specific categories that allow you to take action, maybe train operators or fix the AC, things like that. So very short demo, we only had 10 minutes. If you have any questions, I can take them, and thank you all for coming.